Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves presented to you by Dremio. And here we are on episode 54, How the Time Flies By. And we're going to be talking about mastering semantic layers, the key to data-driven innovation. But with no further ado, I'm going to introduce my fellow evangelist here at Dremio, Andrew Madsen, as he presents to you a really exciting presentation on mastering semantic layers, the key to data-driven innovation. Andrew Madsen, the stage is yours.
Thank you so much, Alex. I'm thrilled to be here, and I highly recommend attending that Apache Iceberg crash course. Apache Iceberg can be so difficult to really understand the impact, and Alex does a wonderful job of being super thorough and making it easy to understand. And that we believe that's the way of the future. So getting on board now is in everybody's best interest. So thank you to Alex for putting that together. So I'm going to share my screen. Just a quick introduction of who I am. So as Alex mentioned, I'm not the host, but I am a developer advocate tech evangelist here at Dremio, working with Alex. Before Dremio, I had some senior leadership positions at different institutions in data, including JP Morgan, LPL, and working all over in data, analytics, data science, governance. And then on the side, I'm a professor of data science and data analytics, where I teach grad courses on machine learning, statistics, and a bunch of programming languages. But today, I really want to talk about semantic layers, because semantic layers really are can be a difficult concept to understand because there's so many definitions out there of what a semantic layer is. But two, it really is the key to innovation. And we'll talk about why. So today we'll talk a little bit about what's the current state of business intelligence. For those not using a semantic layer, what does that look like? What is a semantic layer? How can that help? Where do we see the industry going? And then how does Dremio approach semantic layers? So Alex already did a fantastic job of giving an overview of Dremio and what Dremio can do. So let's dive right in to semantic layers and what's going on with BI right now. And so I would describe what's going on with BI right now in most organizations, not those who are super buttoned up, those who have a clear single source of truth and strong governance and data stewards. I'm talking about the normal organization, most of the organizations that I've worked at. Today, there's so much data where we're collecting data and storing it in the cloud. We're collecting data and storing it on-prem. We're trying to, quote unquote, shift left and democratize data by putting it into the hands of not just practitioners, but to business users. So we've got all this data. We're trying to share it, but now also we have globalization. So we've got data crossing borders. We have regulations like GDPR and CCPA. And all these factors have really complicated the data landscape. So what I've seen is a lot of organizations have become decentralized, more decentralized. They could be federated, leaning towards decentralization with their data teams, meaning that analysts and engineers can be aligned with a business domain. We see that a lot. Maybe they have a center of excellence centrally, which can help give guidance. And that would be a federated model or a truly decentralized model where it's completely separate, where each business unit or domain has their own dedicated data team, and that doesn't talk to other data teams per se. So it becomes more and more complicated. The benefit of decentralization, what we've seen over the last few years, is it allows data teams to be more nimble. But if not done thoughtfully, it can create a lot of data silos, which we've also seen. So there's increased complexity, there's data silos, but also with these federated teams, even if they talk to one another, there's often multiple data definitions and multiple data formats and multiple data types, which makes it really tough to have an analyst from sales use the information generated by the analyst in compliance. So getting on the same page is critical in order to be able to share the data. For instance, at a marketing team that I supported, the business they called a prospect when I was speaking with the marketing leadership. And by managing leads in Salesforce, they were looking at prospects, and then the sales team would call them a client. Same person, different name. And orders and deliveries were managed in SAP. And then the finance team called that same business entity a counterparty. So now we've got 3 different names really for the same thing. And the finance team was using Oracle EBS. So now we've got 3 different systems, 3 different teams, all talking about the same entity, the same person in this instance. Super hard to consolidate that data and make use of it if you really wanted a true customer 360 view or a universal view across that relationship with that person. So in this complex environment, really, how do you get a report that aligns to all, in this case, all 3 of these data elements to one single source of truth that can give us a true view of this client, prospect, business entity, counterparty? Because if I'm in leadership, what did they really want to see? They wanted to see metrics on a single lead to cash, or a report showing time to close, or lifetime value of a prospect. Very difficult when there's different definitions, there's different locations, different source systems, and the teams don't have an easy way to get on the same page and talk to each other. So the solution really lies in having one standard and consistent definition for a business entity. In this case, prospect, client, counterparty. Map it. Make sure that it's all one thing. And so then with this semantic map, let's get on the same page of what's this definition, right? And then we can create a logical model and access that. So just talking about today's state of BI, I would call it data chaos. Everybody's doing their best to get the right data, to analyze it, to get insights, to run machine learning models on data, to fix data quality, and to use those insights to drive value. Very difficult if it's in a siloed or chaotic format. There can be technical and business bottlenecks to this. So a centralized data responsibility, if you haven't federated or been decentralized, if you have that strong central team, which is really good for governance, centralized teams can become bottlenecks. They're too busy. The larger an organization grows, very difficult to manage access, very difficult for them to try to make sure that everybody has the data and the insights that they need across all the BI tools, across the thousands of tables and views. Data silos cause friction. Interpreting the data, even if you get access to a different silo, interpreting the data becomes super difficult because you don't have the context of what definitions they're using, which can be critical if you're trying to create regulatory metrics and report out on these things, or you're rolling them up into an enterprise-wide aggregated view. You need to know that you're rolling up the right things. Super hard if you're not talking to each other. Governance actually is a benefit of strong centralized team, but almost if you're too stringent with it, it can be to the detriment of insights, right? It can slow down the insights so that it doesn't keep up with the pace of business. It's the opposite of shifting left. And then lack of utilization. Well, if we can't understand the data and we can't access the data, we're not going to use the data. What's the purpose then of collecting the data if we can't use it? So this is where the semantic layer comes in. So where does the semantic layer live? So first, a semantic layer serves as an abstraction layer that translates complex technical data into user-friendly, business-oriented terms. That's a lot of words. But how we view a semantic layer is that it creates a layer of data that the business can natively use. There's systems like Tableau, Power BI can talk with the semantic layer in definitions that the business already uses. Semantic layer can provide a source of truth across all the domains because you've done the work of getting on the same page, having this same ontology for the organization, same definition of key metrics. You can create a metric store. So all of these things are incredibly important. So it sits in between the raw data, the ingestion, and the consumption layers. And then what can happen, so we're taking the semantic layer, it's making this data accessible to business users in a way that they understand. They're able to analyze it, access it through applications and programs that they already use and know. And then if they're creating information that needs to be shared back to the semantic layer, for instance, a data scientist who is pulling from the semantic layer into a Jupyter notebook, running a ML model, let's say lifetime value on a prospect, predicting what's the lifetime value of this prospect, can write that back to the semantic layer. So then all the information stays in one place. And there's some critical components that Dremio provides that makes it incredibly helpful. So talking about the benefits, why do I need to do it? We've talked a little bit about why a semantic layer would be helpful in general, but there's some real specific things that I've seen across different organizations where the semantic layer really optimized their analytics, their data science, and their overall data programs. So the first would be simplified data access. So non-technical users can use drag and drop interfaces, point and click tools, natural language queries if they need to, in order to access the data. So simplified data access, super helpful. Self-serve analytics, that's what we're all striving towards. Analytics can be a skill set that any position, any role within the organization can use, as long as they can access the data. So users can explore, create their own reports and dashboards because it's in a language that they know in an easily accessible format. Improve data governance, because the semantic layer really centralizes the data in a place where you can manage business terms, metrics, access controls. You can really ensure consistency and compliance across the organization, but still stay nimble with that federated team structure. So super helpful. And with regulations like CCPA, GDPR, and you don't maybe just do this to stay compliant. You do it to stay compliant, but also for ethical reasons. Semantic layer can make it easy to mask sensitive data or omit sensitive data and make sure that only the right people are accessing that information. Like your HR team shouldn't have the same access as your ops team, right? HR needs to access some more sensitive data. And having that single source of truth, it really makes identifying and categorizing and organizing that sensitive data much easier. And that makes governance easier on the back end. It can accelerate time to insight. So because you're eliminating the need for complex data preparation on the user's end, the semantic layer really allows users to get insights from their data faster. A lot of BI tools, for instance, Power BI, offers, I believe they call it a semantic layer in Power BI, where you're manipulating it with DAX and you're combining the tables and building reports on top of that. But Power BI is one, now we've siloed that semantic model that you've created, and it's harder to share, it's harder to govern, and it's slow. Power BI is a powerful tool. It works best when data is live, but tools like Dremio are made to create those logical models and access data lightning fast, where Power BI is, as a dashboarding and reporting tool, its primary purpose isn't to get that data quickly. That's a secondary objective of Power BI, where with Dremio creating these models, its primary objective is to be lightning fast. So doing the semantic modeling in the right place will drastically impact your performance. And similar with data governance, it's going to help you enhance data consistency. So mapping the technical data to business concepts. Semantic layers really ensure that all users across the organization are working with consistent, standardized data definitions. It reduces the risk for data discrepancies. And the golden goose that we're all searching for is empowering less technical users. SQL is often a gate for non-technical users. They can't get access to the data. They know how to analyze it. Maybe they know statistics. Maybe they're comfortable in Tableau, but they just can't get access to the data. Or if they do, that it's tough to combine the tables for them. Very, very difficult for a less technical user to really get in and be super effective with the data. So by creating a semantic layer, creating a semantic model that less technical users can pull and interact with, while still maintaining the governance, the single source of truth, and the speed, letting them access that model through tools that they're already super comfortable with, low code tools, visualization tools. This is going to help democratize data access throughout the organization. It's meeting them where they are, but providing the central support and consistency to make sure that their analysis is shareable and scalable. So there's a lot of benefits to having semantic layer, but in practicality, how do you actually build one? Or what could that look like? There's a lot of opinions out in the world about what that could look like. And at Dremio, there's some core fundamentals as to what a semantic layer consists of. So you've got the preparation layer. So this is really combining or just ingesting those data sources, virtualizing those data sources. You can leave the data where it is. It could be in Snowflake. It could be in MinIO. It could be in SQL Server. You can leave it there, but we need to centralize it into one access point, Dremio for this instance. So the preparation layer is closest to the data source. It's going to organize and expose the required data sets from the source. You don't have to pull in all the data, just the required data sets, which is super helpful. So in this layer, each view is going to be mapped to a table that they're derived from. And the data source, we're not doing joins in the preparation layer in our model. Typically, a data engineer is going to be the one responsible for preparing the data in this layer. This is where they can apply column aliasing, column data typecasting, data cleansing. They can create some derived columns based on existing columns in the table. So really setting it up for success and getting it clean. The next layer above that is the business layer. So the business layer is going to provide a holistic view of all the data across the organization. It's the first layer where joins among sources are going to occur. And all the views in this layer are going to be querying the sources in the preparation layer A. So querying other resources in the business layer, you're going to be able to start using common terms to describe key business entities in your organization, like customer, product, order. Typically, a data modeler, could be a data engineer, could be a DBA, works with the business experts to get that context. And the data providers, hopefully you have data stewards, but if not, we've got data providers. We probably have somebody assigned to the systems who really understand how it's working and define the views that are going to represent the business entities. You can create many sublayers inside the business layer, really drilling down, each one consisting of views. And you're going to have that for different subject areas or verticals or domains. And these views are reusable components that can and now should be shared across business lines. So it's really starting to join together all these sources, get them on the same page, start making those definitions, those critical business definitions of, okay, what's a product? What's a customer? What's an order? What's an impression? And then at the top, we've got the application layer. So we've prepared the data. We've now gone in and organized it and defined and joined the data into views that are critical and matter and make sense to the business. And we've described those critical business entities. Now we can format these views in the application layer for the needs of our individual data consumers or organizational departments, somebody who needs something specific. So typically data consumers like analysts or data scientists leverage views from the business layer, and they can work directly in the application layer to create and modify views that are going to be used in their own dashboards. So you can see in the application layer, maybe if you're in a large organization, you might have several BI tools and you might have several departments using different tools. They have different needs. So as long as the business layer has accurately defined critical terms and entities, then we can tailor those in the application layer for specific reports and use cases. So this enables us to use a role-based access control. So access to each of these folders or views can be regulated by roles, which is super helpful, super great. Your analyst and your data scientist may have different access than your business user, as they should. It can simplify and secure the process. So using role-based access control in a semantic layer is super helpful because roles are used to organize privileges at scale rather than having to map privileges for an individual user. And so you can create roles and manage privileges for users with different job functions in your organization. Analyst, security admin, admin. So users who are members of a role gain all the privileges granted to that role. And access protects the integrity of your data. It simplifies the data architecture available to those users based on their roles and responsibilities within the organization. And early in an organization, it's critical to define those roles because as it grows and grows and adds more roles and positions, it's more difficult to do that on the back end. Totally possible. But you want your role-based access to be clear before your organization really grows and scales. So effective controls really allow users to access the data that's central to their work and without regard for the complexities of where and how the data is physically stored and organized. They don't need to know that. They don't need to go in and run all the queries or analyze, is this coming from Snowflake or is this coming from SQL Server or is it on the lake? Is it not? Where's this data? They don't need to know that. They just need to know that this is the data that I need to do my job. Here's the definitions and here's what they mean to me. And the data should line up with my definitions. And now I can just access it through Power BI, Tableau, Anaconda, Click, whatever tools that they're familiar with using, because the analysts and the data scientists and the DBAs have done all the work on the front end to get on the same page. So that's really going to optimize your innovation, because now we've got the data cleaned, defined, and available to us across the organization. Now we can get that synergy, which is almost impossible in a data silo. So best practices within the different layers. So because the preparation layer is closest to the data source, this layer, as we talked about, is used to organize and expose only the required data sets from a source. You don't need to pull all the data sets. And we're going to virtualize them in Dremio so they can stay there. We don't physically have to move the data out of the data source. We can create a logical model where we know where it is. That's going to reduce duplication, increase data quality, increase federated queries and speed equals speed to insight, which is what we want. So the preparation layer really is the cleansing layer. We don't have to join everything, but we do need to cleanse things. We need to deal with nulls. We need to deduplicate data. And this really helps centralize the views so that as we go downstream and we start moving into business and application layers, that it's consistent. So it's incredibly helpful in the preparation layer. And this is going to you can create derived columns using columns that already exist in the preparation layer. And this is going to enable all future layers to then use those columns. So thinking of the downstream impact. Then the business layer, again, that's really where the joins come in. So when we join two of these views together, they should be a representation of the view. And this is going to allow changes made to the business layer to propagate to all the joins. And use your list of common terms to describe key business entities. You've got that business context now. This is really where a lot of that hard work happens, is getting on the same page with the business, because you want to provide that holistic view of the data across your organization. It's really where, in my opinion, the magic happens, because in the prep layer, yeah, we bring it in, we do duplicate data, we clean it up. But in the business layer, now we're really able to do that magic of joining data across sources, which, while I led data teams in the past, was incredibly difficult. I had data sitting in Hadoop or Cloudera, and then I had data hitting SQL Server, and then I had a data lake with AWS, and then I had Redshift, and it was all over the place because in a lot of my teams, we were federated, leaning towards decentralized, or we were fully decentralized. Getting the data and combining it together was incredibly difficult, and doing it at scale was very hard. And when you're trying to create AI or machine learning models, or even just enterprise-wide analytics, it was almost impossible. The data quality suffered, the insights suffered, because we weren't 100% confident in the data that we were creating. So there was always a caveat around metrics, and we're like, it's directional because we can't get all the data. So take this with a grain of salt, which is not what you really want to say when you're running an analytics organization, but that's what we had to do. Had we had a business layer where we could combine all of these views and get the data from all of the sources, our life would have been so much easier if we had followed this process. I can think of one time at a university I was working at, where it was a state-run university, and they are subject to the Board of Regents. And so they have to report out to the federal government on certain things for funding they're receiving. They had to report out to the state government for funding they were receiving on particular student metrics and performance. And those metrics had to be buttoned up. We could not be guessing on those metrics. And we pulled the data and we cleaned it and we were confident in it. And then we went to quality check it and make sure that it aligned with all the different units and colleges within the university. And it turned out that some of the data had different definitions. They used the same name for enrollment, for instance, but their definition of enrollment was different from what other areas of the university had used. So now our numbers are wrong, and we had to go back in and create a calculated column on the fly and figure out, okay, what did they use to calculate enrollment, and how does that map to what everybody else uses to calculate enrollment, and how do we get these to combine together in a way that's accurate? Super difficult, huge pain. And had we had a semantic layer where we could get on the same page at the business layer, our lives would have been so much easier, so much more accurate, and it would have built a lot more confidence in our end users trying to make these executive decisions, trying to move fast. Nothing's worse than when a business user knows that your analytics request is going to take a month, or if you're working on a machine learning project that really could take probably like a few weeks, but it takes you 3 months because getting access to the data and cleaning it and checking the quality is the bottleneck. It's a nightmare. It looks bad for analytics teams and machine and data science teams. It's really difficult for end users and hurts the credibility of the data teams, because end users almost stop requesting access or requesting information or trusting the dashboards because they found inconsistencies in it, because maybe there's silos, data quality, different definitions. Once a business user has been burned, that can drive shadow IT. I've seen that where I've come into organizations where they encountered these typical problems of data quality issues, slow analytics, project life cycles, the turnaround time super slow. Maybe machine learning model is a black box, and they can't explain to the business user what the factors were. And then there's shadow IT going on, and I've seen different leaders and domains start doing their own data analytics on, in Excel. Excel's fine. It's not the tools the problem, but it's where they're getting their data. I had a leader, an organization I had just joined, and I was going around and meeting with all the stakeholders and trying to figure out, what is their relationship with the data analytics program? How are they being supported? How are they not being supported? What's kind of the trust level of the information that's being provided and the bottlenecks? And on some critical metrics that were being reported out across the organization, this person's numbers didn't align with what I was calculating, which I was being able to pull from the source systems, or my team was pulling. And so I went and met with them, and they were hand calculating all of these metrics because they didn't trust the information that the data teams were providing. And they had been doing this for years, it turns out. So that's an example. That's an extreme example of what can happen when a semantic layer doesn't exist, a common definition doesn't exist, and then trust is eroded because there's a lack of understanding. So the application layer is really a more specialized layer. So if you're doing a bronze, silver, gold data engineering methodology, I'd say the application layer is like the diamond layer, one above that, because it's super specialized. So it's pulling from the business layer. So we've got the common definitions, common metrics, but it's being specifically specialized to a use case. Maybe a machine learning model. I see it a lot with AI models, which need really specific data in a specific format in order to optimize their performance. Or maybe there's a critical dashboard, which needs aggregated results and needs to run lightning fast. Right? We can create a logical view within that application layer. So the application layer is fantastic. And this is where a lot of the data analysts or analytics engineers will move from the business layer into the application layer. So in Dremio, it's crazy easy to create a view. So if the data analyst, let's say, is looking at the views created in the business layer, they're confident that one, it's been cleaned, and two, that the definitions are correct and that the calculated columns, the metrics are correct and on the same page, then they can specialize that in the application layer. And the nice thing about Dremio is we're not moving the data. It still lives in the source systems. We can virtualize it. If we do want to really optimize it, make sure that those dashboards are lightning fast, you can create what's called a reflection, which can cache some of the most common information used in the dashboard, so then it doesn't have to pull, from a lower level. It can pull from this lightning fast top level, because you want your dashboards, especially highly used dashboards, and hopefully all of your dashboards are highly used, to be super fast. I was meeting with the head of analytics for a FANG company, and he had just joined a year previous. And you would think that, and at least I had the conception like, all of the FANG companies, all the big tech companies are super buttoned up on their analytics, and I'm sure all the best practices are followed. In this case, he was surprised, and I was surprised to learn that it wasn't, and that one of their issues was that dashboards were insanely slow. They didn't want to use extracts because they really wanted live data, which I agree with. You should use live data. Tons of benefits to that. You don't want to do extracts to duplicate your data and then now it's immediately stale. Live data is the best, but their dashboards were insanely slow because they had just been thrown together on the back end, and it didn't make a lot of sense how they were formed, and there was a lot of data duplication. So he went in and followed a similar methodology to what we're talking about and was able to reduce data duplication and was able to make those dashboards just super fast. And by reducing the latency, he was able to build credibility with a lot of his stakeholders, and huge success. So it was really just understanding where to do the modeling and getting on the same page and understanding, core best practices for building a semantic layer or data modeling in general. Because the BI tools make it so easy to try to do all your modeling in the BI tool. It's the worst place to do it. It's so slow. It's going to break. And that leads you to say, okay, well, I'm just going to do an extract and I'll just schedule this extract for once a week. But there's a lot of issues there. Now it's stale. What if the extract breaks? Just do live. What if you could just get it live and get it fast? That's what we want. And that's what we're enabling at Dremio. So after building all of these views, one of the last stages is being able to make sure it's discoverable. So in Dremio, you can create wikis and tags. So leveraging tags helps you enhance searchability. So you've done all this work of building views and getting all of the terminology and the ontology correct and then specializing them for certain applications, but you don't want to get into that silo mode again where you're not sharing data. So what you can do, tags enable you to add these tags to tables and views. It's going to enhance discoverability of your data across your organization. You can search for sets of tables and views based on a tag. You can click on a tag to start a search based around that specific tag. The tagging functionality really enables you to group related objects with that same tag. Super helpful. And objects can have multiple tags because they can belong to different logical groups. So tags is a fantastic way to be able to improve searchability, discoverability. And then wikis. How many of us have joined a new group or gotten access to a new database, new schema, and we just don't know what the data means because there's no notes on it? Maybe there's not a data dictionary or an incomplete data dictionary, or the enterprise catalog is lacking. This is where wikis come in. So you can create a wiki to really embellish your data sets. So Dremio's wiki functionality adds a description to either a space, a source, a folder, a table, a view. This is going to enhance the understanding of the data inside your organization because you can describe what it is, what it means, put the common definition of the columns there to make sure that everybody's on the same place. Now you don't have to find the owner of the data set or the source system and ping them on Slack and say, hey, what does this mean? I just want to confirm this. It's in the wiki. So it enhances self-service. The wiki is extremely useful because it provides the context around the data set. I love when there's descriptions for each column and the content helps users get started with the data. For instance, in the wiki, you can really put whatever you want, and you can put usage examples, notes, points of contacts for issues. Super helpful. So we've talked a little bit about use cases, but in analytics, you're going to unify the data. You're going to optimize your analytics. We're going to be able to try to make analytics accessible so that business users can self-serve through the tools that they're already comfortable with and that they can trust that the definitions of the data that they're seeing is understandable. Some business users are already hesitant to jump into the data. They're intimidated by it. They don't like Excel. So if we can make it as clear and understandable and accurate and accessible as possible through semantic layer, that's really going to drive innovation. The more people that you can have in the data doing analytics on their own in a scalable, accurate, resourceful way, it's going to exponentially improve the innovation and insight within the organization. And one technology that makes this possible at Dremio is Apache Iceberg native compatibility. So because we can leave the data in the source system, but we can virtualize it into Iceberg tables, that makes it super easy for us and you to query the data very quickly and to unify it and get it all in one spot, to do a customer 360, to build ML models, to do enterprise-wide metrics, to make sure that you're speaking the same language across business units and data teams. And I found this in machine learning. So before I joined Dremio, I was on machine learning and AI, generative AI program that was leading to try to really build out AI use cases. And our data was a shambles. And for AI, we really wanted to get as much of the data that we had across all of these different silos into a format that we could ingest with AI and try to build out our generative AI use cases. It was a nightmare, as I've described before. It was all over the place. Definitions were different across different silos. Access was different. We called customer different things in different systems. So how could we build an AI model on top of a reliable AI model on top of that? We couldn't. The data quality was very bad. I didn't trust it. So how am I going to build an AI model on top of it? A semantic layer is going to be able to really unify these things. And if there are different definitions, maybe we make that super clear and push it off. We separate that for whatever reason. Sometimes domains have to have different definitions if they're not rolling up into an enterprise-wide or aggregated view. But for generative AI use cases, generally they are larger scale. So you have to have common metrics, common definitions, easily accessible, cleaned, accurate data. And this is what a unified semantic layer through Dremio can really provide. It's AI-ready data. It's get it cleaned, get it accurate, get it organized, get it accessible, and make sure that the business context is built into the logical model. And then you can run all of your analytics and insights and AI through tools that you're comfortable with. You can do it through Snowflake. You can do it through Jupyter Notebooks. You can do it through Data Robot. Super, super helpful. So no matter where it lives, no matter where it's stored, data lake, database, on-prem, and no matter where you're going to analyze it, whether it's Power BI, Tableau, Python, DataIQ, doesn't matter. We're going to be on the same page because we've done that work of getting a unified semantic layer in place. And that is a enormous game changer for organizations. It's also a competitive advantage. So a lot of organizations don't have this. They're in a bad spot. They're doing their absolute best with getting access to data, trying to clean it, trying to have reasonable data quality, and trying to crank insights out to the right people. Super tough if you don't have a model like this in place. So the AI use case, we're seeing this more and more. And so because data lakehouses are just clearly advantageous for AI, a lot of people are building their advanced models and their AI on top of data lakehouses because it's a great way to really consolidate their data, especially through tools like Dremio. Being able to have that clear view of all of your data is, as we talked about, really going to enhance the interpretive capabilities of large language models, for instance, because you can provide it that structured contextual framework. Let's say in that application layer, which is more specialized, maybe you do make one specifically for your LLM training. But that application layer is pulling from the business layer, which you've already done the hard work of cleaning and getting definitions right. Now we can specialize it using those common definitions and metrics by building an LLM on top of this specific layer. So it's going to help you deliver, more precise and insightful analysis. Really, a semantic layer is an invaluable tool in the decision-making process across all of these domains. soon, I'm excited for Dremio. Soon, vector database capabilities um, will be available in its lakehouse, specifically within Iceberg. So I'm super excited for this. So with this feature, users are going to be able to add a column of type vector to store embeddings for various data elements. So for example, if you have a table of Amazon reviews, you can store embeddings that encode the meaning of each review along with other attributes. And Dremio provides indexes and SQL functions, including fast similarity search, cosine similarity. This is in the future, right? So enabling easy retrieval of similar related reviews based on meaning. So this is going to eliminate the need for a separate vector database platform, streamlining your data analytics process. Super excited for that to be coming to Dremio, especially with all of the AI use cases using vector databases. And also coming soon, not available yet, but coming soon, autonomous AI-driven semantic layer. So a lot of this work we're hoping to automate. So Dremio is going to leverage AI capabilities to enhance the semantic layer by automatically learning the user's data, such as identifying zip codes, providing dataset descriptions. Dremio is going to try to eliminate the need for manual catalog population. Additionally, it's going to learn the workload and create reflections to accelerate query performance. So the AI-powered semantic layer is going to provide efficiency and productivity for users. So those two features coming soon are going to be incredibly helpful for AI. So I know that was a lot. It's a lot of me talking about semantic layers. I'm a huge proponent of them. But at this time, I will stop and pause for questions. Thanks, Alex.
Awesome. We have one question in the Q&A. Is there any way that you can manage data from Dremio to upstream, or are you limited to affecting what's within the Dremio ecosystem?
So managing data to upstream, what would be an example of that? Can you think of an example of that, Alex?
I think they're kind of alluding to is like basic kind of like the problem like that data contract will be solving. So like, hey, can you manage data from like the source systems, which for the most part, I would say no. I mean, this is basically where Apache Iceberg would probably come in, because with Apache Iceberg, you can have a catalog that's working across all your systems. So in that case, the Apache Iceberg allows management to be portable across multiple systems. But as far as like if I connect a database or a data warehouse to Dremio, Dremio can do all the modeling from the point that it gets connected, but it's not going to be able to do any management of what happened before.
That's right. Because we leave, just like Alex said, because we leave the data in the source systems, what's hitting the source system through that ETL process is outside Dremio. Once it's in the system and we're virtualizing it and moving it into Dremio and those Apache Iceberg tables, that's where the Dremio magic happens. But that initial ETL into the source system is outside of Dremio.
Awesome. Right now, I think that is the. Oh, let me see if there's any other questions. Oh, okay. They put in an example in the Q&A. So they said, for example, if I'm managing data within Power BI's data flows, I can only change the data inside the Power BI box. This is a bit dated. Okay. Okay. But I think the context they provided pretty much still alludes to what we were talking about, in the sense that like what's inside Dremio is kind of like basically inside the Power BI toolbox. I mean, one thing I'll add, yeah, okay, he says that we got it. But the one thing I'll add is that even though like the nice thing about Dremio semantic layer is that Dremio semantic, so basically like if you have the Power BI toolbox, kind of like what you pointed out in your thing, if I were to create like a semantic layer in Power BI or Tableau, it's only available to that particular BI tool, while Dremio semantic layer would be available. So that same modeling would be available to all your BI tools. So downstream, it's helpful. But yeah, I think that question's answered.
Yeah, that's 100% right, Alex. That's one of the benefits, is that the semantic layer is universal rather than trying to create, like in Power BI, a semantic layer for every dashboard that is not scalable, shareable. We've got quality and duplication issues there.
Okay, I think that wraps up all the questions. Okay, we'll see you all again on the next episode of Gnarly Data Waves. Again, make sure to subscribe either on iTunes or Spotify, or to subscribe to the Dremio YouTube channel, and check out dremio.com/gnarly-data-waves so always know what's coming up. And we thank you all. And yeah, you'll be able to see this on YouTube in the next 48 hours and also on those podcast streams. And again, thank you, Andrew, for coming on for this wonderful presentation.
My pleasure. Thank you.